Hello friends, in the last lecture I covered the meaning of node, minor node, major node, reference node and non-reference nodes, and I also covered when we say supernode circuit, when the circuit is said to be simply node circuit. Today, I am going to cover numerical problem on supernode analysis. Problem given here is like this. Here there are three sources. One is 2 amperes, other is 1 volts voltage source, the other is another voltage source whose value is 2 volts like this. Similarly, there are three resistors, one here, the another here. And he also mentioned in this node voltage is V1 and this node voltage is V2. So another node voltage is V2 and he asked what is the voltages V1 and V2 using supernode analysis. So to solve this problem, first we have to decide whether it is coming under the category called supernode analysis or not. For this, there are two conditions, means at least one condition should be followed or satisfied to say that it is supernode analysis problem. The first condition is when the voltage source is connected between the reference node and non-reference node, then we say there is a problem coming under supernode analysis. Or the other condition is when the voltage source is connected between two non-reference nodes. So here look at this diagram. So first of all we have to know what is a reference node, what is non-reference node. So if you look at this is one node where three branches are meeting and we say the voltage at this node is V1. Similarly, there is a junction of three elements here. This junction we call as node 2 and voltage at this node we say V2. And these are the non-reference nodes and this is called the reference node. So this is also called ground node. If you look at this, it is the junction of four branches. This is one branch, this is another branch, this is another branch, this is another branch. So they are meeting at one point and this is called the reference node. So if you look at the conditions, is there any voltage source between the non-reference node and reference node? So this is the non-reference node, this is the reference node. There is no voltage source directly between this point and this point. Similarly, between this point and this point. So with that we cannot say this is supernode circuit. So next condition, when the voltage source is connected between two non-reference nodes. So this is one non-reference node, this is another non-reference node. Here we have a voltage source called 1 volt and it is connected between these two non-reference nodes. So it is satisfying the second condition. So we say this is a circuit coming under the supernode analysis. So once we know that it is eligible for supernode analysis, then we have to follow the steps to solve this problem. So let me cover first the steps and then I apply those steps to this problem to get the solution. The first step is, first of all we have to find out how many nodes are there. Second step is assign the nodes and assign the current directions from the nodes. So next third step is write the voltage equation for node 1 and node 2, that is for V1 and V2. Fourth step is write super node equation. Fifth step is solve the above equations to obtain the unknown values V1 and V2. So let us see the first circuit, given circuit. So look at this. Identifying the nodes are over. This is one node, this is another node, this is another node. So there are three nodes. So first step is over. Next, assigning the nodes, that is also over. It's already given in the problem itself. So this is node 1 and whose voltage is V1, and the other node is second node. This is its voltage is V2. And for this, write the voltage equation. That is, if you look at this, this is positive and this is negative terminals. We can write V2 minus V1 as 1 volt like this. This is equation 1. So next, draw the circuit again. So give the current direction from each node. So because once we take a node, we assume that that node voltage is at higher potential compared to the other node. So all currents will emanate from that node. So here one from node 1 whose voltage is V1, there are two currents flowing, one flowing like this, the other flowing like this. So here it is a super node. So no, we don't consider anything. Even you consider current entering here I, and from this another current minus I. So they are going to get cancelled and we treat that as zero current flowing there. So next there is a second node. From this also when we take this second node, we assume that voltage is higher than other nodes, and from there currents goes away. So one current flows into the 2 volts supply, the other current flows through this 1 ohm resistor, and this current won't consider, even you consider it, it is going to be net current in this branch going to be 0 because it is a super node. So having assigned the current directions from the nodes, now we identify what is super node and then write the super node equation. So super node is nothing but this node and this node and this element put together. We call that as super node. So once we say this is super node, so we say that voltage here is V1 is also equal to V2. And for this super node, we have to write one equation. Means we get only one equation. So that is, we are going to use KCL for this super node. So that is, first you take this node. So what is the current flowing out of this? That is 2 amperes. And going out of the node, we treat that as plus sign. So plus 2 amperes. So next, another current is also flowing. That is V1 by 1. So that current is also going away from the node. So we say that is V1 by 1. And that is also positive value. So we write 2 plus V1 by 1. Next, so this is over. Next, you go to the second node. This is second node and again it comes under super node. So from this, the current flowing in this 1 ohm resistor, we write like plus V2 by 1 like this. Then there is another current flowing from here to here. So we write V2 minus 2 divided by 1 ohm. So that is equal to 0. So algebraic sum of the currents at a junction, that is here at super node, is equal to 0. So we have treated this node as single node. Super node means single node. So we get only one equation. So that is what we got here. So then we simplifying, we get V1 plus 2V2 is equal to 0, and this is called the second equation. So we know first equation and we know the second equation. Add the second equation to the first equation, then we get like this. So second equation is V1 plus 2V2 is equal to 0, whereas equation 1 is nothing but V2 minus V1 is equal to 1. So once we add these two equations, then we get V1 plus 2V2 plus V2 minus V1 is equal to 1. So once we simplify this, we get 3V2 is equal to 1. So from this, we get V2 is equal to 1/3 volts. So we know what is equation 1, that is V2 minus V1 is equal to 1. We substitute this V2 to get V1 value, that is V1 is equal to V2 minus V1 is equal to 1 plus V2. So from this equation, we can write V1 is equal to V2 minus 1, that is V2 is just now calculated 1/3 volts minus 1. So we get minus 2 by 3 volts. So for this given problem, we have found what is V1 and V2 using the supernode analysis procedure.